Hello everyone, welcome to Ganit. Good evening. So, as we bring 2024 to a closure, I thought I missed a couple of days. I could not make any videos because we are approaching final exams and there are so many classes to take. So, I thought as we are ending 2024, we should end it on a brighter note. I wanted to discuss a few, two, three questions based on the chord properties of circles that we have discussed already. I wanted to show you guys that how we will approach the theorems, how we will spot the theorems in actual questions, and how we'll go about it. So, without any further delay, let's start with this question. So, I have a question here which says a chord of length 16 centimeter. So, the chord is 16 centimeter is at a distance of 15 centimeter from the center. Remember, guys, if it says in a circle question that at a distance of 15 centimeter, the distance will always be the perpendicular distance. It's not going to be your tilted distance or any other distance. It's always a perpendicular distance. So this here is 15. They're saying the whole chord is 16 centimeter. So as per the theorem that we have studied earlier, the perpendicular from the center will bisect the chord into two equal halves. So this 16 centimeter is roughly what? 8 and 8, right? And this here is your radius. So if you see, this is a very straightforward right angle triangle, and I'm going to use the Pythagoras theorem. So I can say r square is equals to 15 square plus 8 square, which gives me 225 plus 64, which is 289 as the radius square. So radius will be 17 centimeter. Ideally, if you're finding the square root of a number, you should use a plus minus sign. The thing that is there in geometry, why am I not using plus minus sign? Because the radius obviously of a circle cannot be negative. So that's why I'm not using a plus minus. But remember, in general, in algebra especially, if you're using square root, please use a plus minus. Now, the same question goes on to say, find the length of the chord. So we have to find the length of another chord of the same circle. So don't draw two different circles. It's the same circle, which is at a distance of 8 centimeter from the center. So this chord, they're saying, is at a distance of 8 centimeter from the center. So perpendicular distance again. The radius this time around, we know. One circle cannot have two different radii. We can only have one particular radius for a circle. So this time around, when we consider triangle, let's call this X, triangle CXO, then in that triangle, we have the radius. Earlier we didn't have 17, 8, and this part CX is missing. So I can say 17 square is equals to 8 square plus CX square. So 8 square will go that side. So we have 289 minus 64 is equals to Cx whole square. So Cx whole square is 225. So Cx is 15. Now this part, remember the question says find the length of the chord. What we have found is half of the chord. So the chord, which is CD, will be how much? 30 centimeter, just at twice. This is a very basic question. It's not a difficult question at all. But it's important in one context. You get to learn from this question how the radius of two different triangles, the radius in two different triangles, my bad, will stay the same. And that's what we are going to use in finding the length of another chord if it is what the question is asking. All right. Let's move to the next question, guys. I hope this is clear. I didn't apply anything fancy here. Only property, basic property of circle, that if you drop a perpendicular on the chord gets divided into two equal halves. All right. Let's move to the next question. So, okay. So we have a question where it says AB and CD are two parallel chords of 8 and 6 centimeter respectively. So 8 and 6. If they are 1 centimeter apart and lie on the, so this is very important information, guys. Lie on the same side of the center and lie on the different side or opposite side of the center. So I'll show you with the diagram what it means. So we have the center here. So the two chords they are talking about is this. One is 8 centimeter and one is 6 centimeter and lie on the same side of the center. So either below the center or above the center, but on the same side. Okay, they can't be on the either side of the center. So what we do, we draw the diagram like this. This here is radius. This here is radius as well. This is 4, this is 4, this is 3, this is 3. So O, A, B, C, D, this point P, and this point Q. So please remember, the question is saying if they are 1 centimeter apart, that means PQ is 1 centimeter. The distance between the two chords is 1 centimeter. Okay. So I'm again very simple application of Pythagoras theorem again. Nothing special about this question. Okay. The question is saying find the radius of the circle. That's exactly what we are going to do. So this part is given as 1. What I'm going to assume as OP is equals to X. I'm going to assume this part as X. Okay. So talking about triangle OAP, I can say R square is equals to 4 square plus X square. So basically 16 plus X square is equals to R square. Now in triangle OCQ, I can say OC square, which is the radius square, is equals to 3 square, this part, and then OQ square, which is X plus 1. Remember guys, please use whole square. Do not write X square plus 1 square. Use X plus 1 as one single term, put it inside a bracket and then whole square it. Okay. A lot of times in, out of laziness, I have seen a lot of students write this as X square plus 1 square. Please don't do that. Okay. Be proactive. If I am 36-year-old and I can be proactive, I'm 100% sure you guys can be. Okay. Please do not bring out the lazy self of yourself when you're solving a question. Okay. That thing is not x square plus 1 square, it's x plus 1 whole square, and x plus 1 whole square is a plus b whole square. So it has to be expanded as per a square plus b square plus 2ab, the algebraic identity. Please remember that. Okay. Now let's solve this further. So we have r square is equals to 9 plus x square plus 1 plus 2x. That becomes x square plus 2x plus 10 is equals to r square. If this was my equation number 1 and this was my equation number 2, they are both equals to the radius square. So I can equate them individually, right? So what I'll get, 16 plus x square is equals to x square plus 2x plus 10. And from both the sides, x square will cancel out. So what do I have? 2x, I'll keep it this side, 10 transfer to that side, you'll get 6. So x you will get as 3. I'll write it here, x is equals to 3. Okay. So x is equals to 3 means we can go back here and substitute x as 3, we'll get the value of the radius. Okay. So radius square is equals to 16 plus 3 square, which is 16 plus 9. So r square is 25. Therefore, r is equals to 5 centimeter. So this is how you find the radius in this question. Please remember, in the previous question also, if you notice, I had to apply Pythagoras theorem in two triangles. In this question also, if you notice, I have to apply Pythagoras theorem again in two triangles. So please remember, circle theorems is good. You know it, that's very nice. But you can't solve a chord property related question in circles without actually knowing Pythagoras theorem properly. It's a very, very important tool to have and you need to know about it. Okay. So let's move to the next question. All right. So we have two concentric circles of 17 and 10 centimeter. Okay. So two concentric circles, I hope everyone knows what concentric circles mean. Concentric circles are two different circles, but with the same center. Okay, they share the center. So if I have to draw a diagram, one circle will be like this and another will be like this. Now the radius is, so center will be same. One of them is a radius 17. So let me draw this thing. A line segment PQRS. So PQRS. S cuts a larger circle at P and S and the smaller circle at Q and R. If QR is equals to 12, so this part is 12, so obviously we will have to drop a perpendicular. This will become 6 and 6. All right. Now this part is the bigger radius, which is 17, and this part is the smaller radius, which is 10. Now if I mark this point as X, so please understand it's the same story all over again. I'm again going to use the Pythagoras theorem. I'm again looking at a couple of right angle triangles. All right. So I am going to use triangle OQX. I can say 10 square is equals to OX square plus 6 square. So 100 is equals to OX square plus 36, and that means 64 is equals to OX square and OX is equals to 8. So I know that this thing is 8, and this will help me in figuring out PX in the bigger right angle triangle. So I'm going to use triangle OPX, where I can say 17 square is equals to, now I have the value of OX, which is 8 square, and plus PX square. So I have 289 is equals to 64 plus PX square. 64 goes that side, becomes 225. I subtract. Px square is 225, so Px is equals to 15. Now please understand, we have the value of Px as 15. We have the value of Qx as 6. What will be the value of PQ? 15 minus 6. So what you get is 9. So PQ is basically Px minus Qx, which is 15 minus 6, which is 9 centimeter. Again, not a tough question. The only thing is you need to know about Pythagoras theorem. You need to know about the basic chord properties, and then it's all pretty fairly simple. All right. So I hope you have all understood these questions. These are not the only questions that I'm going to do on this theorem. There are at least 5 to 6 more questions headed your way. I want you to start with the fundamentals using these questions. These are basic examples of chord properties, and then slowly we'll build up on it. We'll try and practice more questions from this. All right. I hope you have a very, very good new year. Enjoy your evening. Try not to study maths today at least, and begin your year with a bang. All right. Till then, see you guys later. Bye bye.